All right, so today we're going to talk about giant cane, and we're going to do a lab experiment on below ground productivity. So we're basically going to try to predict, based on these above ground characteristics, culm diameter and culm length, what we can expect to find underground, because there's a lot of interest in folks trying to restore this stuff on the landscape. So they're like the NRCS, U.S. Fish and Wildlife Service, they're trying to get giant cane, which is a native habitat to southern Illinois, back on the landscape. The big problem is they don't know how to reproduce it very well, so they use our data based on some of the allometric equations we developed on above ground characteristics, shoot height, shoot diameter to predict what's below ground. So we want to dig up these rhizomes because we don't have any sexual reproduction with these. These don't go into seed, they don't flower, or if they do flower, it's within its own little genotype, so it's not a viable seed. It's basically inbred. So what we have to do is use the below ground portion, the rhizome, to plant into the ground, and it'll have buds on it, and I'll show you a rhizome here in a little bit. But we count the number of buds. Typically we'll want to plant something that's about 12 inches long with 10 viable buds on it. So we want 10 live buds. So we're going to go through the exercise of showing you how to develop that allometric equation. So the first thing you got to do is lay out your plot. And what we're going to do is come in here and shoot some spray paint on the ground. We want a 1 meter square plot. So we're going to put a dot here in this corner, that corner. We're going to measure out 1 meter square roughly for this lab, and then we will come in with a shovel and excavate everything in this square meter. And I'm not going to do that today. We've done it already. We have the data. We're just going to show you how this works. So this is a square meter plot. Just come in, paint your boundary around the plot. And we're basically going to dig up all the rhizomes in this square meter. So the first thing we'll do is actually cut all the rhizomes, and we just use our trusty snips to do that. Go in here and cut these off. We're going to count them. We got to know how many there are so we can extrapolate that up to a per acre basis. We're going to measure the height of all these and the diameter of all these. So we're going to give you that data set, the number of culms per square meter, the height, and the diameter. So now we've got our shovel. We've got what we call the clod buster. This is the version 2.0. We've developed that over the years. We're going to go in here with a square shovel and basically cut along that yellow line and start cutting squares. These roots for giant cane only go about 10-12 inches deep. You'll see the very dense network. And I've got some pictures from some other labs, but here's how the clod buster works. You just take a clod of soil and start slamming it down on there, and it will knock all the dirt away from these rhizomes. And here's a small rhizome right now. We'll get a better one than that here in a second. But you want to collect all the rhizomes, keep them, because we got to count the buds. We got to measure the total length to develop this allometric equation. And if we were wanting to do this for restoration purposes, we'd come in here with a moldboard plow and drop it down and pull it through here to get our rhizomes, because what you see we're doing here is cutting these rhizomes, and it's only 3 inches long. We're looking for something 10 inches long. Here's a viable bud right here. So at every node, here's a node, here's a node, and this area is the inner node. Viable bud, viable bud. So that would be 2. About 3 inches long, 2 buds. You could actually plant this and it would grow, but what the buds will do, they'll either turn into another rhizome or they'll turn into an above ground culm. You can see how dense these rhizomes are underground. And the reason they want this species restored is for water quality benefits. And if you look at that, that's just a dense blanket of rhizomes in the upper 6 inches of the soil. So you can imagine what that does for soil stabilization. They plant these in riparian zones. Look at this. 4 rhizomes right there within a 6-inch square of soil, and they're still coming out. There's tons of viable rhizomes in just this little half a square foot of soil, and that's a good example of what a culm looks like where it attaches to a rhizome. So you can see it originates at that internode, at the node. That was a viable bud, shot up into a rhizome. Other ones can be like this, and they'll shoot off into another rhizome. This one turned into a culm. This one on top turned into a rhizome right there. And you can still see viable buds here at every internode. So those are going to turn into either a culm or a rhizome. And then you can see the fine roots in addition to all the rhizomes that are going to hold that soil together. So just in this half a square foot, and we got some pictures that we'll show you in the video to show you how much density there is in a square meter. But this is just this is 36 square inches basically of soil, and you can see all that biomass. All right, so we got a culm. Here's what we're going to do for the above ground measurements. Put this at 0. We'll run it down here to the end of the tape, and you measure the longest leaf up here. About 54 inches is what that was going to be before it came apart. So down at the end of the tape, we're at 56 inches for this culm in terms of length. And then we're going to measure diameter with the caliper that we used in the glaciation study. Here's the caliper. Close it. It's right at 10 millimeters or 1 centimeter diameter. So we're going to use that data, the height, diameter, to predict this, how much is below ground. And then when we quantify these, what we're going to do is measure them. So we want the total number of buds below ground. We're going to measure this one. This one's 9 inches long, and we've got 1, 2, 3 viable buds on this one. So 3 viable buds, 9 total inches. If we looked at this one, we got 10.5 inches. We've got this bud already broke. It was another rhizome. There's a bud there. There's a bud here. There's a bud right here. And that's it. So there's 1, 2, 3 viable buds on this 10-inch piece. And we're going to go through and do this for the entire square meter. So you're missing out on a lot of fun here. 1, 2, 3, 4, 5, 6 per rhizome. And we want to count the number of internodes too. So there's 1, 2, 3, 4, 5, 6 nodes. So that'll be the same number of internodes on this one. So number of nodes, number of live buds. That's what we're looking for in this. And we'll just go through and quantify all these for the whole square meter. So you really missed out on probably an hour and a half of fun of measuring these and then adding up all the data. But this is what it looks like below ground. Here's the above ground portion. And remember, this came from about 6 inches of 6-inch square of soil. So that's dense, very dense. We've seen a lot of good stuff with water quality with this. We've seen sediment reductions, basically reduced from whatever was coming at the ag field edge down to 0 by 10 meters in this. So a 10-meter riparian buffer, we saw 100% reduction in overland flow. Pretty good reduction in groundwater as well. But there's also a lot of species that are dependent on this canebrake habitat. And if you look back at the early settlers that explored Illinois, there was expansive canebrakes of this stuff, about 7 miles wide, they would say. So they were hiking through southern Illinois and they'd come up to what they called impenetrable thickets of giant cane. So this stuff was a big component of the landscape. Now it's not nearly as big, but it's just kind of in these little sporadic communities around here in southern Illinois. And the further south you go, you get down into the Cache River area, there's a lot more canebrakes down there. But there's, like I was saying, there's a lot of species that are dependent on this. There's about 7 different insects that use giant cane as their habitat. There's a couple different birds. One's extinct, the Swainson's warbler, and then the Bachman's warbler, that use this habitat for nesting. So without the giant cane habitat, they don't have successful nesting. So the rattlesnake, there's a canebrake rattlesnake. Some people call the swamp rabbit the cane cutter. So there's a lot of species. The black bear used to use this. There's a lot of species that were dependent on this habitat. So the Cache River is denoted as a Ramsar wetland, is what they call it, and it's one of the top 10 highly recognized wetlands in the U.S. and this is one of the critical habitats they identified as part of that ecosystem. So that's why there's so much interest in getting this back out on the landscape. So when we're talking about the restoration of this, say this is a viable culm. We want something that's about 10 inches and has a few viable buds on it. So you want to plant this thing distal end down on an angle in the soil. So you'd take a tree spade and put it in the ground, and you'd have a little bit of it sticking up. You want most of your buds buried in the ground, and you want them pointing up. So these buds can turn into a rhizome, or like I said, they'll turn into a culm above ground. So there's been a lot of different methods for restoring this. Dr. Zajac has done a lot of research on this, trying to find the best way to do it. However, the orientation, this way, that way, but what he found was about a 45-degree angle was best, with the buds pointing upwards. So that's the best way to get this stuff in the ground. And then we plant this stuff on about a 5-foot spacing. So every 5 foot, put one of these in the ground. And these, as you can see, are a running species. So this is going to be like a rhizome underground that's going to run and shoot up multiple culms along the way, and it just kind of slowly spreads. So like I said, sexual reproduction, a viable seed, is not really an option for restoration. So they're using asexual reproduction, where they're putting these rhizomes in the ground. If you look at the canebrake behind us, this is the one that we established in 2008. So we used several different phenotypes and genotypes in here. They came from different sources across the Cache River. So we used these to restore this site basically and put this nursery here, so in the long term we can bring lifter in here or a moldboard plow and pull some of this stuff up and actually do some restoration projects. So we need to know how much to harvest. If somebody ordered, say, hey, let's plant this 40-acre bottomland in giant cane, we need the material to do that. We can come in here based on these allometric equations and dig the right amount of cane without wasting a whole bunch or not digging enough. So we've got this dialed in to where we can predict how much we need to remove based on the density, the height, and the diameter of these culms.